All right, good morning, guys. Today is Thursday, the 28th. Let's see here. We are going to be doing pages 445, 446, and 447. All of these are dealing with word problems, things like that for the most part. Um, at the end of this, we're going to be multiplying with mixed numbers in word problems. So we're going to look at mixed numbers as well, which which is going to be important to focus on, but it isn't a huge change in what we do. We'll talk about a couple different strategies that we can utilize. Um, as you've realized, well, if you've been paying attention, you've realized that we are transitioning and just kind of getting into that shortcut that we've been talking about. We'll talk about that. We'll go over that here with the example, and then into question number one here. This first couple of pages, 45, 46, is going to be, I'll do this page mostly with you. The next page will be on your own. And then 47, we'll talk about those strategies. Okay. So here we go. This says Vicky's favorite beach towel is green and white and has a fish design. The green part covers 5/8 of the towel. The fish design is drawn on 3/5 of that part. What part of the towel has a fish design? Okay, so we can draw a picture for this. Okay, so they go ahead and draw and they show this is the towel, right? This is the whole towel. Okay, the 5/8 is shaded green because that is the green part of the towel, right? So here's this towel. It's mostly green, a little bit of white on it. Okay, there's fish that are on 3/5 of the green part, right? So they went and drew fish in 3 of the 5 parts. Pretty straightforward, right? Okay. Because 3 of the parts of the towel have fish shown on them. 3/8 of the towel has a fish design. 1, 2, 3 out of the 8. Correct? Well, this works really well because this is fifths and this has 5 parts, right? That's the reason why it works out as easy as it does. But the second that's a little bit different, it gets a little trickier. Okay, so just something to be aware of. Okay, so which is going to be why things don't work out as easily, things like that. It's going to be important to understand that they can work. We'd have to adjust it and things, but it's going to be easier just to write it and solve the problem like we're going to look at right now. So it says you can also write an equation to solve the example. Write the numbers to complete the equation showing what part of the towel has fish designs. So we know that it says there are 3/5 of that part meaning this, right? That part is referring to 5/8, right? Okay, so this is saying 3/5 of 5/8, 3/5 of 5/8. We've talked about this numerous times at this point. If we say of, we're talking about multiplication, okay? A fraction of a fraction, okay? We're not dividing, we're not subtracting, okay? So we're talking about a fraction of a fraction. So 3/5 times what? Well, again, 3/5 times 5/8. And that is equal to 3 times 5 over 5 times 8, okay? All right, and that's going to equal when we multiply across here, so it's going to be 15/40. All right, they got an answer of 3/8 though. That's not 3/8, is it? Well, that's the one thing about this is when we use this strategy, oftentimes, not always, oftentimes we're going to have to simplify, okay? Okay, is your answer in problem one the same as the answer of 3/8 shown in the example? Well, yes, it is the same. It's the same value, right? Is your answer number one the same as the answer? So yes and no. I mean, technically, Yes, it is, because it's the same value, but no, because it's a different fraction, right? Same value, just as so I would explain this as, yes, it is. Yes, it has the same value, but it needs to be simplified. So I'm going to show that real fast. So if I have 15/40ths, if I divide, well, what number can go into both these easily? Well, this one ends in 5, this one ends in a 0. So I know 5s work. Okay, divided by 5/5, which I know I'm making an equivalent fraction because that's just dividing by 1, right? That equals 3, 8, because 40 divided by 5 is 8. 15 divided by 5 is 3. So it's to show evidence why it works, okay? So I'm gonna let you go ahead and continue that thought process and continue on to page 446. I'm gonna jump ahead. This is where you should pause the video, finish your section, and then when you're done with that section, come back and join me on page 447 here as we start looking at using whole numbers, not whole numbers, mixed numbers, along with fractions, right? Or I guess, or mixed numbers by mixed numbers, even if that becomes the case. Okay, so it says Janie, we're in Janie, has a rectangular garden that is 2 3/4 yards in length and 1 yard in width. She grows roses in half of her garden. How much square yards on Janie's garden? So let's see here. So this is how big this is her length and this is her width, right? So we'll say this is the width. So we'll say W is here. W is going to be equal to 1. So we're going to say this is the length, and the length is equal to 2 3/4, right? Well, I'm actually going to go ahead and I'm going to go ahead and separate my mixed numbers and my whole numbers. So I'm just going to go ahead and put this as 2 over here. And this over here will be my 3/4. This works because this is 1 and this is 1 here and 1 here, right? That's where my 2 comes from. So I have 2 wholes over here. And this one's going to be 3/4 of a whole, because this whole box over here is 1, right? But we're going to have only 3 of the 4 parts of this shown, right? So we're going to go like this. This is garden. This is not garden, okay? Only the shaded spots are garden. So again, all of this is garden too, right? I guess I'll shade it just. So all the blue area here is considered garden. So now, what we're going to do is we're going to multiply this by a half, right? So we're gonna go ahead and on the width here, we're gonna make it a half. So to make it half, we're gonna cut it right down the middle, aren't we? So now we have 2 parts, 2 parts, 2 parts. And so then this is a half, and this half over here I guess I'll do this one as well, just showing us all the way across. But all we care about is the overlapped space, right? The overlapped space. So over here, we have just the top half and just this top half. Well, the two halves together, oops, 2 times 1/2 is equal to 1, right? Okay. So the idea is that I have 2 halves. That equals 1. I have a whole. You could have also just said, hey, I have 2. What's half of 2? And you just thought about it. What's half of 2? Which would have been this idea, right? We're just drawing that out let me write now. But also if I have 2 and I cut it in half, would be like this because there is 2 in it, right? I would take one of them, so that works too. This one over here, though, I have 1, 2, 3, 4, 5, 6, 7, 8 total parts, correct? And there's 1, 2, 3 parts being represented. That is equal to 3/8. Okay. I can also represent this as an as an equation. Sorry, I can't think right now. It'd be 1/2 of 3/4, and therefore 3 times 1 is 3, 4 times 2 is 8. This can't be simplified. So now I'm going to put these back together here, right? I'm going to take my 1, and I'm going to add that to my 3/8. 3/8. I'm going to just recompose it after I decompose it. And so we're going to get 1 3/8. So 1 3/8, 1 3/8 squared, so yards squared has roses. Okay. All right. So there's a couple ways that we looked at it here. Okay. We looked at it using some equations by separating it out and using the equations, right? Okay. So multiplying by the whole number first, and then multiplying by the fraction part, and then putting it back together. That totally works. We drew it out, which works as well. But let's look at a different strategy now. Okay. We have 2 3/4 times 1/2. Okay. If we just leave it like this, it makes it potentially a little harder. We can always multiply 2 times 1/2 and 3/4 times 1/2, and that would work, right? Like we just did up here, and just do it all together here. But I can always look at this and say, oh, I'm going to convert this into an improper fraction and then multiply, which is a great strategy, and a lot of you will ultimately probably end up using that for some time. So if I go ahead and do this, I'm going to go ahead and take this 2. The 2 is going to become, I'm going to switch the 2 into fourths, right? I'm going to switch the 2 into fourths here because I have fourths, because these are fourths here, right? I'm going to switch this 2 wholes into fourths, which is going to be, well, 1 whole is going to be 4/4, so 2 wholes are going to be 8/4, right? So that's 8/4. And then I'm going to add that to 3/4, correct? I'm going to multiply by half. I'm just going to put this all together now. I'm going to get 11/4 times 1/2. Now I could go ahead and multiply across. I get 11/8, correct? Well, naturally, we still need to convert this back to a mixed number. So 11/8, well, 8/8 is 1 whole, right? So I get one group of 8. So 8/8 is 1 whole. The difference between 8 and 11 is 3. So it'd be 1 3/8. So either way, we get to the same number. For some of you, you're going to feel like you need to draw it out, not that for now, and do that as long as you need to make it make sense and make sure you're understanding that. Okay. Some of you are going to be able to multiply this and be able to like, oh, I know this because 1/2 of 2 works this way, and then 1/2 of 3/4, I can just multiply that and then put those 2 parts together. Some of you are going to want to, hey, it just makes it easier if I can just get into one equation, one problem, mix it and go to an improper fraction. Maybe you can switch between mixed numbers and improper fractions really quickly. Okay, if that's the case, that's knock yourself out. That works really well as well. I personally like to just multiply it by looking at fraction times the, like we did up here, fraction times the whole number. Again, now it's not always going to be a back into a whole number, but it can get you into another fraction, things like that. Remember, so as a reminder about this, if I want to treat this like that, I can always say 2 is equal to 2/1, right? Okay, so then I can multiply that by 1/2, correct? Theoretically. And so that would be 2, that would be 2. Well, 2/2 is equal to 1. And that's why this one does work out that way. Obviously, if we have a different fraction, let's say we were multiplying, let's say it was 2, instead of having 1/2, let's say it was 3/4. Let's not use 3/4, let's use 3/5. We use 3/4 up here. Let's just times by. So I turn this over times 3/5. So this would be saying 3/5 of 2, right? That would get me to 6/5, which would equal 1 1/5, right? And so we could totally do it that way. And then if this had a fractional part of it, if this 2 had 3/4, then I can multiply the 3/4 times 3/5, right? And that would get me to 9/20. So then I would need to then add this back into this. And now you can see where it kind of gets a little bit different, because now if I have to add this back into this, now I have to find a common denominator, which I'd have to change this to 20ths. So this become 1 4/20. Now I can add my 9/20, and this would become 1 13/20. If I did my math right, I may have did it wrong. So I know someone out there will at least check it, unless I made a mistake somewhere. But anyways, the point is that there's a lot of different strategies we can take when we solve this. When you look at page 448, you can see more of that modeling that we talked about. So just understand that as we start moving forward and we have mixed numbers in there, and then we'll get into mixed numbers times mixed numbers as well. And just what does that look like? Mixed numbers times whole numbers, and kind of how all of that changes. And it's going to be following the same types of ideas we're doing in this. It's just going to present a slightly different challenge each time. Okay, so it's going to be important, which is why we're slowing down for these sections. Hopefully I didn't mess up and accidentally skip some of those. I think I got all those. So we're going to continue that tomorrow. All right, guys, I will be on a couple things real fast. I'll be on from noon to 1 today. Mr. Ann will be on from 2 to 3. Mrs. Morris, I believe, will be on earlier. I'm not sure exactly what time, but I think she goes on from 11 to 12 usually, but sometimes that changes. So again, make sure you go check in with the other teachers. Try to check in with your teachers at least once a week. All three of us, just even if you're just saying hi, check in with them during the class hours, so we can see how you're doing. Check in with your math. Look at some of your math with you. Today sorry, I said Mr. Ann from 2 to 3. I was wrong. I don't remember. Actually, Mr. Ann is from 1 to 2. If I said 2 to 3, I'm wrong. Mr. Ann is from 1 to 2. So Mrs. Morse typically is 11 to 12. I'm from 12 to 1. Mr. Annan is from 1 to 2. Today we are going to be I'll be posting into my classes, all three of them, a social, our Google Meet social. So make sure that if you want to come join us, go ahead and click on the link that we'll put in there. Just remember to be respectful during that process, and we'll have some fun, give you guys a chance to see each other and everything. So yeah, talk to you later. Goodbye.